Welcome to this session on database connection pooling. This is part of our system design series. We will explore how to efficiently manage database connections for scalable applications. Connection pooling is a technique that creates and maintains a cache of database connections. These connections can be reused across multiple requests, thereby optimizing database interactions. Think of it as a ready-to-use set of connections, which are represented by C1, C2, C3, C4, C5, and C6 waiting to be used, rather than establishing a new connection every time. Without connection pooling, several problems arise. Firstly, high latency occurs as each request needs to establish a new connection, causing significant delays. Secondly, resources are wasted because constantly opening and closing connections consumes system resources. Thirdly, poor scalability is observed, as the database becomes overwhelmed with numerous concurrent connection requests. These are the problems we face without connection pooling. Connection pooling offers many benefits. Firstly, it leads to improved performance by eliminating the connection setup overhead, resulting in faster response times. Secondly, it ensures resource efficiency through optimal utilization of database connections and system memory. Thirdly, it provides better scalability by handling more concurrent users with controlled connection limits. Lastly, it offers streamlined connection management with automatic handling of connection lifecycle and recovery. Here is how connection pooling works. Step 1. Initialize pool. A predefined number of connections are created. Step 2. Request connection. The application requests an available connection from the pool. Step 3. Execute query. The connection is used for database operations. Step 4. Return to pool. After the operation, the connection returns to the pool for reuse. Here's a typical connection pool configuration. We have the following parameters. Minimum connections, specified as min_connections, maintains a minimum number of connections in the pool. Maximum connections, specified as max_connections, sets the maximum allowed connections to prevent resource exhaustion. Timeouts, which include connection and idle timeouts, manage resources efficiently. Here is a sample code block that has these parameters as pool_config, where min connections is set to 5, max connections is set to 20, connection timeout is set to 30, idle timeout is set to 600, and retry attempts is set to 3. There are several popular connection pool libraries available. For Python, SQLAlchemy offers built-in connection pooling with multiple pool implementations. For Java, HikariCP is a high-performance JDBC connection pool with minimal overhead. For Node.js, node-postgres provides a PostgreSQL client with built-in connection pooling support. For C#, Entity Framework offers automatic connection pooling in .NET applications. Here are some best practices and key takeaways regarding connection pooling. Monitor pool metrics and adjust sizes based on load patterns. Set appropriate timeout values to prevent resource leaks. Use connection validation to ensure healthy connections. Configure retry logic for connection failures. Key takeaways include that connection pooling is essential for scalable applications, proper configuration prevents performance bottlenecks, choose the right library for your technology stack, and regular monitoring ensures optimal performance. In summary, connection pooling transforms database performance from a bottleneck to an advantage. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.